Hi, in this video, we will explain to you about probability and mathematical statistics 2, STA256 interval estimator. First of all, I would like to introduce our group member, which is me, Khairi Mattin.
And Assalamualaikum, my name is Muhammad Mustaqim. Let's get started.
Firstly, we will move to question 1. We have 1A, 1B1, 1B2, and 1C. We will answer every question and explain how we get them. For 1A, we need to add up all of our outpatient sample divided by n, and our n here is 20. When we add up everything and divide it by 20, we get 33.8 minutes. For B1, we need to find the 90% confidence interval. So we need to find the alpha first, which is 0.1. And our n here is 20. So n is less than 30. So it satisfies the condition of using Z distribution because n is less than equal to 30 and our variance is known. So when we use the Z distribution, we put in the values. Finally, we get 29.938 to 37.662. Now for B2, we need to find a 95% confidence interval. Same as B1, but our alpha is different. So we get 29.198 to 38.402. So for 1C, this is our variance of population distribution. For this question, we need to find the n, alpha, and s squared. And for n is 20, alpha is 0.05, and our s squared we need to find manually. So x, the summation of xi minus x bar squared over n minus 1. So we finally get 82.63. So after we get the values, which is n, alpha, and s squared, we can put in the values in the distribution. So, and finally we get 47.79 less than equal to variance hat less than equal to 176.26. So for our interpretation, we are 95% confident that the true variance of outpatient waiting times is between 47.79 and 176.26 minutes. This shows the waiting times vary significantly, and the hospital could use this to improve time management. So now we move on to question 2. For question 2, we have 2A and 2B, and we will explain how we got the answer for 2A and 2B. So for the answer, we need to find the confidence interval for variance 1 over variance 2. So this is our distribution. So we need to identify the S1, S2, N1, and N2. So our S1 is 14, S2 is 25, N1 is 9, and N2 is 12. For the F, which is more than equal to variance 1 over variance 2, our F is not specifically in the F distribution table. So we add up the V1 of 10 and the V2 of 8. So, and divided by 2, we find the mean. So that is our F value. And finally, we will get the answer as 0.153005 less than equal to variance 1 over variance 2 less than equal to 2.38. For 2b, we need to use x bar 1 minus x bar 2 plus minus z alpha over 2 times variance 1 over n1 plus variance 2 over n2. For n1 and 2, variance 1 and variance 2, we have identified earlier. And for x bar 1, it is 78, and x bar 2, it is 84. After we identify the values, we need to put in the values in the distribution. And finally, we will get negative 9.7389 less than equal to mu1 minus mu2 less than equal to negative 2.2611.
And lastly, for question 3A, calculate point estimate for average and standard deviation of bottle drink volume. We understand that average, which means X bar. So just input the formula. And the second one is find the 99% confidence interval for the average volume of bottle drink. Assume that population is normally distributed. So let's jump to the answer.
First thing first, to determine the x bar, you need to sum all of the x over n and you will get the answer. And for second one, to find standard deviation, you need to find variance first, put in variance formula, square root it, and you will get standard deviation. And for Roman 2, first thing first, you put in the exact formula and then eliminate the modulus, as you guys can see, and then just put in the number and you will get the answer. So that's all for the topic. Thank you for watching